Can you hear me? Vivek,
Yes, sir.
can you test your screen sharing?
Yeah, 1 second. Are you able to see my screen?
Yes, I am.
Okay.
Try to share the presentation and test it the full screen mode, the slideshow.
Okay. Are you able to see this?
Yeah, and
Okay.
go try the slideshow.
This is going to be work for the summer.
Is this what you want me to try?
I don't see anything.
You don't.
You want to share not the application but the entire screen. In this case, when you do slideshow, I can see it. Yeah.
Okay.
Okay, go ahead. I believe you're right now sharing the application.
Yes, sir.
You want to share the screen.
Okay.
The entire screen. Okay, and go ahead for the slideshow. Yeah, that's good.
Okay.
Okay, let's get started. I think Mega came first, so she's going to start first.
Okay.
Mega, you ready? We can't hear you. You are muted.
Oh, sorry. Can you see my screen?
Yeah, but it looks strange.
Yeah.
You want to switch to your own screen? Yeah, not to mine, not to.
Okay.
So you want to?
Now?
Yeah, that's better. And go ahead for the slideshow.
Okay.
That's good.
My presentation is about peer-to-peer video streaming application, and I'm using AStream for the presentation. So the system application architecture for AStream it's like there's three parts. There's server, there's controller, and there's clients. The client has three modules, controllers have three modules, and server also has three modules. The PM module of the client sends request to the PM module of controller, and the controller sends the request to the server PM module. And in response, for the client request module sends the request to the controller module, and controller module sends the request to the server module for the video, and in response server acknowledges streaming module to the controller streaming module, and controller will respond to the streaming module of client. So in the peer module there's no changes to the cache if the message will send by peer, and when a new peer joins the network, it sends the request to the controller, which replies with acknowledgement containing a unique peer ID. And request module makes a request to the video object that is not cached in the system. And once the video is requested, object is cached in the system. This is an diagram about video streaming. How the client sends request to the controller on the data streaming, and the controller works as a medium between client and server. It sends request. The client sends request to the controller, and controller will be sending it to the Server will send the data streaming direct to the client, but via the controller, and then client updates it to the controller. Now, peer-to-peer streaming sends acknowledgement that reduces the uplink throughput of the client. This is the home screen of how A-Stream looks like, and the A-Stream box is the server of the A-Stream box as a feed to the couple of viewers for the first level viewers, and then it works as a mesh pool based network. Viewers can create a mesh pool based network, and each viewer has a couple of peers who establishes a new direct connection with it and shares data with its peers. Application layer multicast. The multicast functionality in end systems, and end systems participate in multicast via an overlay structure. Overlay consists of application layer links. Application layer link is a logical link consisting of one or more links in an underlying network. The media streaming has two types of it's like ALM and peer-to-peer, and ALM has a tree pull based and tree push based and mesh pull based. Tree push based has it works as the nodes of the trees, like content flows from root to children along the tree, and the node failure affects a complete subtree. One node is if one node fails to stream, then the other nodes won't work, and it takes a long recovery time. In the mesh-based, nodes exchange data availability information with neighbor nodes, and it is resilient to the node failure. High control overhead, and the metadata exchange through it consumes a lot of bandwidth. Longer delay for downloading each chunks. This takes really long to download the video chunks, and the request response takes really long time. The P2P scheme allows information to be shared or published through direct communication between terminals. The end terminal sends an inquiry to a discovery mechanism within the network to find end terminals that have requested file, and then receives the file directly from one of the discovered terminals without the server being involved. One of the advantages of the P2P scheme can be over the client server scheme is that is far less expensive because there's no need to set up the data center. Um, A-Stream uses four platforms. It uses audio and video on demand, live broadcasting, localization of foreign BitTorrent traffic. It's a decentralized social networks and interactive over the top. The basic components of A-Streams are the four players that has A-Stream HD, A-Stream P2P multimedia plugin with the use of YouTube, and A-Stream Player HD, and the TS Magic Player. A-Stream HD, it's a cross-platform application for working within the BitTorrent network, and A-Stream P2P multimedia plugin, it's a multifunctional web player based on a libVLC plugin for web browsers. It basically uses the VLC player and plugins for the different kinds of web browsers. Ace Player HD that allows a user to play online video and audio content via torrent files. And TS Magic Player, it's a play online audio and video content on any website containing links on torrent files without the need to download torrent files. Users do not need to download the files. They can directly play it over TS Magic Player. There are some measurements for the P2P streaming which I have read over internet. It's the most important measurement for P2P streaming is quality of services, and then the scalability, security, robustness, uplink utilization, and fairness. Quality of services jitters less transmission ensures good media playback, and it's a continuous supply of stream content ensures no jitters, and the difference in time between playback and at server and uses less latency. Internet dynamics and congestion in the interior of the network, and but that degrades the quality, and lower latency keeps users interested. Like scalability serves as many users as possible with an acceptable level of quality of services, and increasing number of nodes should not degrade quality. An effective overlay node topology and high uplink throughput ensure scalable systems. Security implicitly affects other P2P streaming measures. Generally, attacks are on P2P file sharing system. Rarely few attacks are on streaming. Still, the attack possibility cannot be denied. There are total like four types of security threats: the malware and the viruses and all. It's the A robust and reliable P2P system should be able to support with an acceptable levels of quality of services under following conditions: the high churning, the node failures, and the congestion in the interior of network affect which and the effects of to the quality of services. Efficient peering techniques and node topology ensures robust and reliable P2P networks. The uplink is the most and it's an important resource in Swarm. Swarming is like distribution of video chunks. It's on internet. It's summation of uplinks of all nodes is the load taken of the server. Utilization. How do we find the utilization? So there's a formula for that. The uplink used, and it's a division of uplink available. Needs effective node organization and topology to maximize uplink utilization. High uplink throughput, that means more bandwidth in the swarm, and hence it leads to the scalable peer-to-peer systems. Now, fairness, it's a measured in terms of content served to the swarm. The formula for the sharing ratio would be uploaded volume, and it is divided by downloaded volume. Randomness in Swarm causes severe disparity. Many nodes upload huge volume of content. Many nodes can get a free ride with no or very less than contribution. But it must have an incentive for an end user to contribute. P2P file sharing systems like BitTorrent use a tit-for-tat policy to stop free riding. Not easy to use. It's streaming as nodes procure PCs in real time and applying the same tit-for-tat cost delays. Current issues regarding the current issues in the peer-to-peer systems are like high buffering time for streaming. Half a minute if someone wants to view or download half a minute of a video, it takes more than 2 minutes for the less popular videos, and if there's a popular videos, that takes less times to download or buffer. Some nodes lag with their peers by more than 2 minutes in playback time. Better peering strategy needed, and the uneven distribution of uplink bandwidths. It's unfairness of the streaming. Huge volumes of cross ISP traffics, and there's ISPs use bandwidth throttling to limit bandwidth usage, degrades QoS perceived at used, and suboptimal uplink utilization. Thank you.
Okay, thank you. Did you find out in what way it is different from Soplink?
I think Soplink or Subcast.
Subcast, yeah, I'm sorry.
Okay. I think Soapcast uses tree-based. I'm not sure about it though, but I think it uses a tree-based, tree push-based network, and this one uses what was this one uses sorry. It uses mesh based.
And can you find any comparison between the two in terms of performance, in terms of scalability, maybe in terms of support? Because as I know, Subcast is no longer supported technology. They discontinued the project development several years ago, but A-Stream has active development as of now. At
Yeah.
least it was a year ago. Did you
Okay.
find anything about this?
I haven't really used any of those, so I don't know the difference between the performance by them.
Okay. What about the server that plays the role? Is it supposed to have all pieces to get started, or how, for example, a system can run without a centralized server? Or is it possible to run it without a centralized server?
I don't think it's possible without running it on a centralized server. We do need it a centralized server, so
But how would peers can find out about each other
yeah.
without a server?
I'm sorry, I haven't looked into
How
that.
would peers will find each
Yeah.
other without a server?
Okay. I don't know about that. I
Okay,
haven't
and
looked into
which sources did you use?
sources for the measurements or
Oh, for your what your research is based on? What articles, what texts, will
uh,
find information?
I don't remember the name for the book, but the book it was by Eric something, and the book cover was red.
But it was a book, right? It,
Yeah,
it wasn't the website that actually gives you the idea of the A stream.
yeah.
You read
I
in the
mean, I did look for the A stream, and I also read the book about peer-to-peer video streamings.
okay, good. Vivek, you ready?
Yes, sir.
Okay, go ahead.
Can you see my screen, sir?
Uh, do the slideshow. Yeah.
Okay. So my presentation is about Open Garden, and Open Garden is just a new way for phones to communicate to each other without, well, not just phones, but any devices that have Wi-Fi or Bluetooth to connect to each other and send messages without using the traditional cellular towers. So the cellular towers are not part of this Open Garden. So what is Open Garden? Open Garden is a software-based network, and so it doesn't use any cellular towers. So all the communication is done from one device to the other device through Bluetooth or Wi-Fi. And this kind of a network is also known as a peer-to-peer wireless mesh network. And the technologies that are used for this is primarily Wi-Fi and Bluetooth, and now it's Bluetooth LE, meaning Bluetooth low energy, so it doesn't use as much power as the old traditional Bluetooth. And Open Garden was created as a virtual private network, and it just sends connections or just messages between devices, and it's mostly done over Bluetooth, but it also uses Wi-Fi if it's necessary. And here are some features from Open Garden. And the first one is seamless connectivity. This feature enables users to connect any supported device to the mesh and thus to interact without any installation, configuration, or pairing. Open Garden uses different physical ways to connect in general, where devices learn about each other in a variety of ways instead of Bluetooth discovery, including through a cloud service and using local chatter. So here what it's saying is that the user doesn't need to just doesn't need to find other users. The Open Garden does it for them. So the Open Garden senses other users using the application on their devices and just connects them seamlessly. So if a user of Open Garden can look on their app and see what other Open Garden users are in his location, and then send data to them. And Open Garden also has channel bonding, which lets users access the internet using only one path. Open Garden introduces a new way to access the internet over multiple paths at once. And this basically is just multiple ways to access the internet. And so before each device had to have their own one path to the cellular tower or the one signal, but through Open Garden, it uses all the devices that are connected to it. And so one path can go through one device, and one device can go through another device, and that device can be connected to Wi-Fi, let's say. And it also has automatic path choice. So once connected, devices can find a path to the internet also completely automatically. If a path fails, a new one will be chosen, and if necessary, new connections will be established with other devices. So let's say my phone can, with Open Garden on it, can be connected to my iPad with Open Garden, and that iPad can be connected to Wi-Fi. So my phone doesn't have an internet connection. It uses the connection that's on the iPad, and the iPad uses the Wi-Fi. So, and the more devices are added to the path, and if it looks for the best paths that are needed, the fastest paths. And it also has multi-hop, which means if there's no direct connection, the devices will access through internet through the chain of other devices. And it's basically what I just said. If my phone doesn't have internet, if it's connected to a device that has internet and has open path, it uses the internet from that device. So it's kind of like a mobile hotspot, but the connection is connected to only one device. It's not making an entire Wi-Fi connection. It's just giving one certain connection. And so what makes this unique is a seamless device discovery and pairing. So it just makes it very easy. The user doesn't have to do anything. The app does everything for them. It has offline identity, meaning if even if you're not using it, you still have an identity with it. Let's say you have your app, you have Open Garden installed on your phone, but nobody else in your location has it. So that puts you offline. But once another user with Open Garden is identified by the app, it automatically takes you online and connects you both together. And it has a proprietary network protocol for addressing and routing messages off the grid. So the proprietary network makes it all secure, and also and it says off the grid, meaning not connected to any cell tower. So even if a device doesn't have a Wi-Fi connection, let's say you go hiking or something, and you're in the middle of nowhere, and there's no Wi-Fi, there's no cellular connection. So the only connection is between one device's Bluetooth and the other device's Bluetooth or Wi-Fi. And so you can go to places and use and communicate with each other without any on the grid kind of connection. And it also has distributed algorithms for managing mesh networks. And so the algorithms are used to find the users and basically make the mesh network, and also to identify the right paths that give the best connection to each user. And it has advanced traffic management. It has multi-hop, store, and forward. And multi-hop is what I just mentioned earlier, but store and forward is, let's say you send a message to one person, and and but they don't have any connection, and they're far away from you, so Open Garden cannot reach them. So the message is stored on a device that was connected to your Open Garden, but when that device goes closer to the person you're trying to send the message to, once they connect, the message is sent. So the message is stored on that one device, and once the device is closer to the other device, it's forwarded to the person you need. And also it has battery use reduction, meaning use of Bluetooth LE, so it doesn't use as much power as the old Bluetooth. And now I'm going to talk about an app that is made by Open Garden, and this app is makes use of Open Garden, and it's available to download right now from like for Android or iPhone or whatever. And that app is called FireChat. And FireChat is basically Open Garden, but it's made for phones. And Open Garden was released like the concept was shown about 4 years ago. So in that time, they created the app FireChat, and FireChat lets you do all the things that Open Garden does. It lets you instantly send messages and photos to anyone around you. So now it's not just messages, you can also send others photos. And it lets you send private messages that only you and the recipient can read thanks to end-to-end encryption. And so you can also send public messages to everybody who has FireChat on their phone. But at the same time, you can also send private messages, just like the DChat app we've been working on lets you send private messages and public messages to everybody. And it lets you create live chat rooms for discussion on any topic with a few people or as many as tens of thousands of simultaneous users. So that's basically, it's a public place to put your message for everybody. And it also has hashtag support, and it also lets you see the most popular messages in the public conversations. And so I think it's basically the most viewed or the most commented messages. It basically puts them in like a ranking. And like we said, it's off the grid, so it works without any internet connection, without a phone or data or Wi-Fi or anything. And all you have to do is leave your Wi-Fi and Bluetooth on so that they can connect. And they connect with one another within 200 feet of their location. So you can go to like smaller places and use it, but I don't know if anybody would want to go on like a hike or something where there's no connection. I think right now they don't have that great of a range, so I wouldn't do that. And like I mentioned earlier, it has multi-hop and store and forward technology, just like Open Garden, and it lets you create larger networks with several people. And here is just you see 3G and 4G. That's how how traditionally phones are connected to the internet. But you see between each phone there's a separate connection, and those connections are basically like Bluetooth and Wi-Fi. And as you can see, there's so many phones that are connected. You could basically create like a whole range of network. As long as one person has a connection to the internet, you can have a whole network with people on the other side of the globe. Dr. Vibe, is it okay if I play a video?
Yes, sure.
Okay.
FireChat creates a new way to communicate with our phones that does not require a data plan or even a network. It's an app for iOS and Android, and it's completely free. Here's how it works. FireChat connects our phones directly with one another. When two phones are less than 200 feet apart, they automatically connect. You don't need to do anything. Just leave Bluetooth and Wi-Fi turned on, even if you don't have a Wi-Fi connection. If there are more than two phones, they create a larger network. It's called a peer-to-peer mesh network. With FireChat, you can send both public and private messages through this new kind of network. Public messages can be seen by everybody. Private messages can only be seen by the sender and the recipient of the message. These messages are encrypted so that no one else can read them. Now here's where it gets interesting. A private message may transmit through several phones to reach the recipient. It's almost as if each phone is acting as a postman, passing the message to the next postman, but without seeing it. Again, only the sender and recipient of a private message can read it. But what happens if you want to send a message to someone who's not part of your local network? It's simple. Just send the message and forget about it. Remember, people move all the time. They'll carry your message to the next local network and so on. And what if you want to send a message to someone far away, yet you still don't have internet access or cell phone coverage? Well, it's the same thing. Just send your message. It'll travel through the local networks until it finds a phone that does have internet access, and your message will be delivered. FireChat uses the cheapest and fastest connections all the time. The more people use it, the better it gets. That's the opposite of traditional networks, which become congested when too many people use them. So let's recap. With FireChat, you can create your own communications network to send both public and private messages, and it's free. But remember, you need enough people around you to make it work. If you live in a city, it'll take about 5% of the city's population using FireChat to cover the city. Get FireChat now with a few friends and start your own network.
Okay. And FireChat also now it opened itself up to make it pretty much open source so that other people can use FireChat, their mesh kit, and implement it into their app. So a mesh kit is a software module that partners can embed into their add peer-to-peer mesh network connectivity to their app or device. So other apps can use the mesh kit to make their app work like how FireChat does. And it also is cross-platform. It works with iOS and Android. And it's basically the same thing as OpenGarden off-the-grid routing. And it has traffic management and multi-hop and store and forward. And it also automatically connects to other devices, to people that are nearby. And seamless content exchange, so it pairs the devices and finds the best path, and the user doesn't have to do anything. They just have to leave it on and let the app do the work for them. It's battery efficient, and it's free, and it doesn't use much battery. And for the security aspect, because your message it travels through different phones, it uses end-to-end encryption so that your messages aren't, so that people who the message travels through are not able to read the message. That's it. Do you have any questions?
How about that one person, for example, using OpenGarden, and he shares his internet connection, his cellular internet connection, and then, for example, there are 5, 10, I don't know, many people on this same OpenGarden network on this mesh, and they just deplete his data plan. Is there any way to control, for example, that I want to share not more than say 500 megabytes when I am connected to OpenGarden?
That's a good question, but right now I don't think there's a way to limit the data used. But I think that yeah, that's a good concern, because people might be sending pictures that use up a lot of data. So right now there's nothing to stop them from that.
I noticed that OpenGarden app for Android, at least, was last time updated on April 2015, so it is about a year without any updates. Not sure about our iPhone or other markets, but did you find anything about like development has been stopped or any other reasons for the application not to be updated?
I think they're concentrating more on FireChat now. So
But
they're using
FireChat is not for the like general internet access; it's just for the chatting.
Yes, sir.
and you only can chat with anyone else with the fire chart. You cannot, for example, use it to deliver any other type of messages.
No, sir.
Okay. And for example, if I'm using fire chart and I have my own 4G connection, and the person to whom I'm trying to access also has 4G connection, would it select direct 4G link between us, or it will prefer us to be connected through the mesh of FireChart?
Yeah, the default is to connect with through the Wi-Fi and Bluetooth, but it only uses the 4G connection if they're not within 200 feet. That's the only time it uses 4G or cellular data.
And did you read any bad things about FireChart or Open Garden?
When it first came out, there was a problem where if you wanted to stop FireChat or Open Garden, I think it had trouble like turning off the Bluetooth. Like the only way you could have stopped it was turning off the Bluetooth so that others stopped discovering you. But I think now it's been fixed, so there haven't been really any issues. The only thing is maybe the security could be a concern.
Okay,
Yes, sir.
good presentation. Thank you.
Thank you.
Okay, nobody else is here. We're good to dismiss. I'll stay online for a while if someone else will join us, but you can leave. You've done a good job.
Thank you, Dr. Brown.
Thank you.
I understand. Okay. My topic was about. Can you hear me, Dr. Bag? Can you hear me, Dr. Bag?
Yes, I can.
Okay. My topic was on own cloud.
Can you share the screen?
Yes. I'll share it.
It's the left arrow icon on the left.
Screen share.
It's green arrow. Okay, go ahead.
Okay. I did my research on OwnCloud, and OwnCloud is a is a file sharing, file synchronization software. It actually provides your own cloud, like the name suggests. So OwnCloud is pretty much a web interface, and also actually it also has a desktop interface where and you can set up your own cloud. Of course, to set that up, you will need a server to set it up, and it's cross-platform. Actually, not the server. The server is not cross-platform. It has to be set up on a Linux. But the desktop client software can be accessed from a web browser anywhere. But I mean, pretty much, OwnCloud is used to manage and protect data on your premises. It doesn't have a data limit because you're using your own servers. You're using your own infrastructure to provide cloud service to yourself pretty much. And like how big and how small it is depends on what kind of infrastructure you have available. Of course, and I found that it wasn't easy to install it. Of course, I couldn't install it. But you can use your own IT to manage it, and you can integrate it with your existing systems and policies. What else? The core of it is the the OwnCloud server. You have your own web interface, and it is written in PHP and JavaScript, which is what makes it cross-platform. You can use OwnCloud on any platform that supports JavaScript. So the goal of this was to provide cloud services without forcing user to use OwnCloud's infrastructure. And you can use it on tablets, mobile phones, and you can sync files and directories. So one of their prominent
Prabhu, you're still on the first slide. Is this how you planned it?
I'm on the slide with the goal.
No, I can see the first slide.
Okay, let's see. I'm on the fourth slide now, and third slide.
Okay, so now I can see the fourth.
Okay. I think if I go on full screen, it's on the first.
Yeah, stay in the window mode, otherwise
Okay.
you're not getting synchronized.
Okay. All right. One of the prominent services was their calendar synchronization service and calendar and contacts. And for that, they use WebDAV, which is web distribution and versioning, which is an extension of HTTP. And pretty much their file sync works, just like standard SFTP, and they have their own way of versioning it too. I think they use what kind of versioning? It's just like have you heard of I mean, it's like a trash can versioning, which is what SyncThing use, but these guys have a similar form of a versioning. And pretty much if you if you have a file across each computer, I mean, of course you can have as many users or systems as you want on one server. Depending on your configuration and the amount of RAM you have, you can extend it, which is one of the advantages of OwnCloud. And every time you update a file on one of these users, it is updated only on that. So I mean, on that computer, as well as when you open it up on a different computer, it's already updated. They have a card system where each file is assigned a card number, and it's a randomly generated number, and every time you make a change to one of your files, the number changes, and then now the OwnCloud knows that the file has been changed, and it goes ahead and updates it on the server. um, and like the versioning, that's one of the other advantages. You can actually revert to a previous version of the file, and it changes depending on what kind of rule you have set up on it. Depends on your settings. um, uh, but I think the standard one is when you just created it, a few seconds ago, it keeps just one version of it, and then after 10 minutes, it maintains a version of it every 1 minute, and after an hour, it maintains a version of it every 10 minutes, and after after 24 hours, it maintains a version of it every hour, and after 30 days, it maintains a version of it every 24 hours. So after 30 days of not using a file, of using a file, you can revert back to every single day of it. And of course, all other versions of it are deleted, depending on how your settings are saved. And their architecture is it's pretty simple. You're gonna have your own server, and then you have your database layer, and the database is still gonna be where your server is, and the users get to access file actually the resources of the server. And it's pretty simple. There's really you asked me to compare it with SyncThing. I think that they're both open source software, and OwnCloud is free. I think you pay for additional perks, such as if you want to buy software from the third-party vendors, you can do that. But apart from that, it is very similar to SyncThing, except in OwnCloud you have to have your own server, and versioning wise, OwnCloud and SyncThing are very similar. OwnCloud is from the documentation that I found, I couldn't find any disadvantages of OwnCloud on OwnCloud's documentation, but I did found some trash about them on SyncThing's documentation. OwnCloud is a lot harder to set up, especially because you're setting up your own infrastructure, and then you do have a centralized server that everyone can access, and that everyone can kind of communicate to each other through. SyncThing is SyncThing provides you space, and you don't have to have your own own server. And I think the latest version of OwnCloud provides you with server-to-server communication, where you don't have to have one single point of failure, where when something fails in one server, your whole cloud is come down. So now they're allowing server-to-server communication, where you can set up more than one device as your server, and they can communicate between each other. That way, if there's one point, there's not one point of failure. And let's see. Yeah, I already talked about the WebDAV protocol, and how they use e tags and timestamps. But is there anything else you wanted to know about this, Dr. Baev?
Did you read anything about inability of the OwnCloud to sync like really fast? Because that's the criticism that I read about. If you, for example, have it installed on a desktop,
Yeah.
and on, say, your laptop, and you change files on your desktop, then it will take an hour, for example, for those changes to be reflected on your laptop, even if you stay within the same network, within the same everything.
Yeah.
People just complain it's too slow.
Right. I think they might have changed it now, because previously, now you have the e tags, where where every file is given a tag, where you could every time you make a change to the file, they keep a log, a central log, where each file is given a tag. And the tag is a randomly generated number, and every time a file name is the number on the tag is changed, the central server notices a different, and it updates the file. But I think the problem is that the main problem could be because we have our own centralized server. And of course, you did mention that some people had problem even when everything was on a single network. But I really don't know what could cause it. I know that they've made improvements based after that.
Okay, I probably need to check the latest version, because I believe what I read was with the previous version.
Yeah, and they have documentation available for everyone. But then I think this is something that the user can personally have to figure out. That's I think one of the other disadvantages of OwnCloud is it's not for everybody. And then looking at how you have to have your own infrastructure. That will mean you have to have your own IT. If you're just one single person, I would suggest something like Dropbox. But no,
Okay, sounds reasonable.
yeah. I mean, does I remember you explained something about Dropbox. I couldn't catch it. What was the difference between Dropbox and OwnCloud?
The biggest difference is that Dropbox is running on the server that you have no control about.
Right. Oh yeah.
They can just get your files and do whatever they want with them. It's pretty much any proprietary cloud sharing has the same disadvantage. As long as you don't own the storage, it means you just host your files anywhere else. It's pretty much the same criticism as we're too heavily rely on Google services, and one day it shuts down, our entire world will shut down. But
Yeah.
that's more like a speculation rather than some real criticism.
Oh yeah. But don't you think if they were the one that are providing a storage, and they're the one maintaining it, wouldn't it be more efficient? And of course, privacy and integrity is a matter of concern. But
I think as long as you don't control completely your infrastructure, you will have all these doubts.
right, yeah. What do we use? We use at GSWCM?
It's proprietary part of our storage. It's the hardware came with the software solution, and it is completely server based. It's just one server. So this is how our cloud is implemented. It's proprietary piece of software that probably will not work anywhere else except on our hardware.
Right. So what are the chances of intrusion for our system?
Chances for intrusion controlled by our firewall, and if this software is known to be good in terms of security, and I believe they keep tracking all the vulnerabilities and all the common problems, and moreover, I keep it running behind the intrusion detection system. So there are many layers that protect like our data. But the good thing about this is that it is under our control. It is not anywhere else. Even though it is called cloud, it is our cloud. It is here. It's from distant points. It's very similar to OwnCloud, We just manage that piece of software that is here and nowhere else. It is local.
Right. And let me ask you this about users and I mean, how often are users updated? And if a person is not a student anymore, how long would it take for?
I usually keep student user records for 2 semesters after graduation.
Okay, okay.
This is completely automated process. I just at the beginning of semester update the records, and it picks up current students from the RAIN. And if a student is registered on classes, then it will be kept. If it is not registered on classes, then it will look 2 semesters back.
Okay, so you can control everything.
Yes, I do control it.
Okay, so there is no other administrator. You're the one that runs this.
That's
right?
correct. Yes.
Okay, that's cool. That's it, Dr. Bob.
Okay, thank you.